All right, good morning, everyone. Today we're going to be talking about function composition. Okay, and the whole idea you want to really understand about a function composition is we're going to be taking multiple functions and basically inputting them into one another. Okay, it's kind of an interesting idea that we're going to discuss more, kind of go into more in depth, and hopefully be able to understand it by the end of this lesson. Okay, so first off, let's just understand really what's happening here. If you notice over here, we are given our first notation. Okay, y equals f of g of x. And the key thing I want you to understand is that typically we always be given the values of f of x or g of x. Well, now you want to understand that they're actually taking this whole thing and plugging it in for that x instead. Okay, that's kind of the key thing to understand. I'm taking the whole g equation and filling it in for that value. Notice how this is on the inside of my f of x parentheses. Okay, that's kind of a key thing, all right? Because we want to understand just why does notation look like this? Why is things in this particular area? Well, this g of x is now replacing that x right there. Well, that idea of just replacing the x is the whole idea of this lesson, okay? And that's kind of the main thing I want to go into it so you understand that. So let's just talk about like a basic chart here. Okay, let's say this is our T chart, and this is our C chart. Okay, so basically what they want us to do is go across the line and basically say, if I plugged in a 4, what would my answer be? Well, for the first one here, T of 4, that's like going to our T chart, going to where it's 4, and pulling out whatever answer we get. So T of 4 has to be 16. Okay, going through the same process, C of 4, same idea. Now I'm going to go to my C chart. Oops, went to 16, not to 4. Go to my C chart, which is 4, and then see my answer is 110. Okay? So see how I can pretty much go through and see like, okay, this is this, and then this is this. I'm looking for the x value, and then the answer is whatever comes from that. But now let's talk about letter C. They give us C of t of 1. So let's just talk about this in the first place. First off, what is t of 1? Well, if I go to the chart over here, t of 1, there's 1 would give me an answer of 4. So what this is telling you to do is take that 4 and plug it in for the c. So we're going to take the answer from the 1 value and plug it into the next one. So now because I found what t of 1 is, that came out to be 4, now I'm going to find c of 4. And if I plug that in, c of 4 is right here, which gives me 110. Notice how there's actually a direct correlation across the board here. Okay? I plugged in 1 for the area. The time took 4 hours. I took that time of 4 hours and found out it was a cost of 110. So the whole idea of today's lesson is that we're going to be taking a composition, which is, you can be seen as like a function within a function, the answer one problem plugged into another problem. Okay, like all of that works. In the last step here, we have C of t of 4. Well, the same thing. We're going to find t of 4, which is 16. So really, this is asking for C of 16, which comes out to be 350. So this is kind of the idea of what we got going on right now, is that we're taking either an answer of a previous equation or an answer from a problem or things like that to actually build off of this. Now, this is kind of the basics, kind of the beginning version of this, okay? What we obviously want to get to is actual equations themselves. So you notice at this point, problems 7 through 11, we have f of x equals x squared, g of x equals 2x minus 1, and then h of x equals 4x minus 3. Okay, all written at the top of the page up here. And we want to basically try to figure out, 1, what is a evaluating problem, and then 2, what is an actual true function composition? So let's kind of talk about these. In letter A here, they give us g of f of 2. Okay? So So the first thing I want to figure out is, what is f of 2? Well, x squared is f of 2, so I'm going to plug 2 in for the x. That comes out to be positive 4. So notice how I use the x squared equation and I plug 2 in for the x. Well, now, because I got the answer of 4, I'm going to plug in g of 4. So my inside value I solved, and whatever I got, I plug into the outside value. So now g of 4 would be 2 times 4 minus 1. That'd be 8 minus 1, which equals 7. And 7 would be my final answer. So you see how step by step we go through this? The number tells us what to plug into the first function, and then the g tells us what to build off of. Well, let's look at the same type of problem, like 8a here. But let's talk about how it differs. In the first one, I could go step by step and solve it, right? Oops. Because we had an actual value in for the x. Well, now I can't do that. I have g of f of x. This is telling me that I'm going to take the f of x equation and plug it into the g. Notice how it's inside the parentheses of the g. So this tells me I'm going to take f of x, which is x squared, and then g of x, which is 2x minus 1. And I'm going to plug that value in for the other x. This would become g of f of x equals 2. That x gets replaced with an x squared minus 1. So notice how all I did was change this to this old equation of f of x. Now, one thing you can kind of think about, and this is where it gets kind of cool, and this is where it kind of builds off of each other. Think of what happens if I plug 2 into this formula. If I did g of f of 2, and I plugged it directly into that formula, that would give me 2 times 2 squared minus 1. And if you simplify that, you get 7. Well, notice how these two are the same. This one, though, this one here, I used one single equation to solve that, while the other problem, I did it by steps. Okay? And this is kind of the main idea of function composition. I'm going to take an equation and plug it into another equation. Now, we're going to go through the rest of these in class and just talk about them, but that was kind of the basics of the lesson. Go ahead and make sure you're answering the answers to questions, and I will see you in class tomorrow. Have a great day.